Now, the hardest part of this unit is when you're given equations that are not in y equals, and you have to turn those into y equals before you graph. But the process and the goal are the same. You want to find the point of intersection and then check your answer. So let's dive right in here. So let's do this first equation. I'm going to move it over here, and I'm going to say 2x plus 2y equals 4. So I'm going to turn this into y equals so I can graph it. So I'm going to subtract 2x from both sides. Now, as a review, remember, boys and girls at a dance. So I get 2y equals negative 2x plus 4. They can stand next to each other, but no combining. Now the next step is I want to get y by itself, or 1y. So I'm going to divide every term by 2. So this becomes y equals negative 1x plus 2. Now we have one of the equations rewritten. And so now we have to rewrite the second equation into y equals form as well. So let's subtract 3x from both sides of this equation. Got to be very careful. This stays as negative 2y. This, once again, boys and girls at a dance. They can stand next to each other, but no touching. And now I'm going to divide every term by negative 2 to make sure the value in front of y is positive 1. So we get 1y equals, now we have negative, negative, so I'm going to do positive, positive, 3/2 x. Positive 6 divided by negative 2 becomes minus 3. So now I have both equations written in y equals form. So what I'm going to do from here is I'm actually going to erase the work that I did leading up to this point. So I have both of my equations here, looking a little bit cleaner than they did before. So let's graph both of these equations. So for blue, our b value is 2. So I'm going to go up here and graph my b value of positive 2. And then I'm going to find my slope, which is negative 1, or negative 1 over 1. Down 1 over 1. And I can do that repeatedly until I want to make a line. Now it's easier on the computer if I go all the way to the edge before I make the line, and it ends up looking like that. I'm going to redo that though, because my board likes to get a little bit off. So let's try it one more time. So I'm going to try to stay clicked down as much as I can. There we go. That looks a little bit better. So there is my first line. So now let's graph the red line. So our b value here is negative 3. And my slope is positive 3 over 2. So I'm going to rise 1, 2, 3, and I'm going to run 2. And wouldn't you know, we actually hit right on the nose. That's pretty lucky, as it definitely does not always hit right on the nose. So let's finish graphing our line. So now we have graphed the two equations. So now let's find the answer, or find the solution to our ordered, or our system of equations. Well, it is right there, which is the ordered pair 2, 0. So our system of equations has a solution of 2, 0. Now we have to check our solution algebraically by plugging it back into either equations. And now we have an option, because these equations are equivalent and these equations are equivalent. You can actually plug it into either or, but I'm going to plug it back into the two original equations just to show you that. Most people plug them into the y equals, and that's totally fine. So 2 is our x, 0 is our y. So let's plug them in. first equation up here is 2x plus 2y equals 4. So I have 2 times x, which is 2, plus 2 times y, which is 0, equals 4. That is 4 plus 0, which does equal 4. So we have a true statement. Now we have 3x minus 2y equals 6. Let's do that. So 3 times x, that's 3 times 2, minus 2 times y is 0, equals 6. 3 times 2 is 6. 2 times 0 is 0. 6 minus 0 is equal to 6. So we have a true statement. So this problem had 3 steps. The first step is converting them into y equals so we can easily graph them. We did the graph. Step 2 was find the solution to the system of equations, which we did as 2, 0. And then step 3 is just checking your answer algebraically by plugging it back into each equation and making sure you get 2 true statements. So that's systems of equations. It's definitely not an easy topic, but the nice thing about it is this is as hard as it can possibly get. Graphing the lines, find the solution, and then check your answer.